All right, welcome, welcome. So if you guys are in, I want you guys to take a second really quick, and I want you guys to come over here to this lab bench and grab one of these periodic tables. We got two packets or two piles of it. So come on up, maybe grab a handful, grab one for your partner, do that. We need to get some colored pencils in here first, right? So I'm gonna grab some colored pencils and we'll pass those around and get that going, all right? All right, so everyone should have a periodic table, right? And it'll be an extra long piece of paper, right? And what I want you guys to do now is I'm gonna give you guys a couple handfuls. Oh, you've already got them, that's awesome. All right, I'm gonna give you guys a couple handfuls of colored pencils. Please put the phones away, thank you. All right, I want you to pick 3 different colors. All right, pick 3 different colors. And what's left over, just pass to the partner behind you, next to you, or whatever, right? Yeah, you just have to choose 3 colors, right? So you could do brown and blue and pink, and then pass the others to everyone else, all right? If it's not sharpened, let me know, raise your hand, and I'll get a sharp one to you, all right? We got pencils going around for you. Like, it doesn't have to be perfectly sharp, but yeah, they just need to be decently sharpened. We're not trying to make the next, you know, Picasso or anything. You want, oh no, you already got pink. It's orange. Nope, we're gonna need color pencils for that.
This is a color.
Multiple colored. All right, so take those. You want green, orange, and red. How about that for you, Luke? Here you go. What colors would you like? Got pink and green and blue. Want pink, green, blue? Good mix. There you go. All righty. We got orange, green, silver. How's that? Good mix for you? All right, all right. Who needs colored pencils still? Oh my word, I sent pencils back. Blue and purple. Let's see if we can get that. Here, grab some colors.
I got enough both of those.
Oh, awesome, awesome. Okay, I'm gonna put these in the middle here. Right, here's the purple.
Wait, how many?
We need 3 of them, all right? Doesn't matter what 3 you choose, just make sure they're different colors, all right? There is a sharpener, but I'm gonna come back and, how did you end up with 3 broken ones? Oh my word. So I'm gonna come back to you and give you a new set of 3 that's got enough lead to take care of it, all right? Pass these back, there's 4, that way you can choose what he wants. All right, who else needs some more? Cedric, you need some? Pass these back to him. There, I'm still working on names, I know. There's 3. All right, and then you still, oh, those are great. Well, we'll sharpen them later. Don't worry, don't worry.
Mine is multiracial.
All right, and then here's 3 colors for you. Awesome. All right, everyone got colored pencils? Right, Luke, we got colored pencils? Everyone got papers? All right, awesome. Now that that's out of the way, you know, firstly, welcome, you know, thanks for getting all settled in. Thanks for getting colored pencils, right? So what you're gonna do is you're gonna set all of those to the side. We'll address those at the end of class, right? Or for the remainder of class once we're done with presentation, all right? What I want you to do is pull out your packets, the elemental tail packets. And really quick, I just wanna see how far you guys got on page 7. I just wanna double check, see that we got everything done, and then we can get through. All right, 7 is done, awesome. All right, really quick, I just want to summarize, see how well you guys have retained this information from yesterday. If I say that something changed color, right? Changed color, am I looking at a physical characteristic or evidence of a chemical reaction? Evidence of a chemical reaction, right? But we are also still looking at the color, right? It's a physical change, right? Now, I want to give you guys a conundrum, right? A little crazy little question, right? If I'm going to take, say, baking soda, right, and I decide to put it in water, right? You guys have done baking soda and vinegar before. I decide to put it in water, and I see as I'm stirring it, right, the liquid turns white, right? Does that mean that there's a chemical reaction going on?
No.
I'm hearing yeses and nos. All right, someone who said yes, be brave. Tell me why you think that there's a chemical reaction going on. Go ahead, Luke. It says color change, right? Yeah, the water turned white. I could definitely see that. But the trick is when you add, say, too much sugar to water because you're trying to make lemonade, what happens to the sugar? It clumps after it starts dissolving, right? As soon as it's dissolved too much, it clumps up. What are you going to say, McKee? Is it really? Or is it just dissolving? Oh, that's what you're asking. Sorry, I didn't hear you quite right. So yeah, when you add food coloring to water, right, or you add too much salt, baking soda, or sugar, right, it changes the water, but it's not necessarily a chemical reaction, right? Yes, yeah, it makes a mixture, right? So we're going to throw a couple of curveballs at you guys for the test coming up in a week and a half or so. And there might be a question like that on there where you might say, oh, iron and sulfur, I know that. We did that in the lab. I'm going to say it's a chemical reaction, right? But maybe if you read the whole of it, it's talking about how it was making bubbles, right? Or, I don't know, changing temperature, right? Do we know that those things happened with the iron and sulfur, right? We don't. What were the signs that we saw of the iron and sulfur causing a reaction, being a reaction? Yeah, we definitely smelled it, right? That was a major indicator, right? So we got smell. What was it? Yeah, we saw a couple of bubbles when we added, what was it, the acid to the iron, right? Yeah, so it takes a combination of chemical chain or chemical reaction evidences for us to know for sure that it's a chemical reaction, all right? So keep that in mind. Hello, Ike. All right, so just wanted to summarize that. We feel good on physical properties and evidence of chemical changes. Give me a couple of thumbs up. Feels pretty good. All right, so let's get into the rest of the pack here. I want you guys to pull up to page 11. Right? And we're going to take a look at the periodic table. All right. So we've already got on page 10, we've got a whole list of elements with their names and their symbols, right? So on page 11, we're talking about how to organize all of these elements, all right? So let's get the slate turned on. Here we go. So periodic table was the work of quite a few. Oh, before we go on, let me double check the chat, see how we're good. Okay. Wonderful. Yeah, he's in the library. All right, so for the periodic table, make sure it's working. Come on. There we go. So the periodic table, guys, keep it together. Periodic table was made by a lot of different scientists all over the world. Right? We had some scientists say, I want to organize the periodic table based on their charges, which we'll talk about later, right? I want to talk about how to organize the periodic table or the elements based on their color, right? I want to organize them based on how much they weigh, right? So most scientists did that, right? They looked at the atomic weight. Who here has never heard that in their life? I'm okay if you haven't, it's all right. Someone brave, awesome. We're gonna learn about it today, right? So, well, I wanna give a high five to everyone once the day is done, all right? So the atomic weights are what it sounds like. It is the weight of one atom of an element. Right now, here's a question. If all of the elements are a little bit different, do you think they'll have different atomic weights? Yeah, so each atomic weight is going to be unique to the different elements we have, right? So that's how people were organizing it. And then one guy, John Newland, said, hey, when I organize it by weight, it's not perfect, but it makes a pattern. I can see some sort of pattern that follows every eighth element to a point, right? It's not perfect, but it's pretty cool, right? So who here, raise your hands, who here plays an instrument, like maybe the guitar, piano, violin, clarinet? Who here sings, right? So a lot of us have heard of what's called an octave, right? If I have middle C, how many keys on a piano do I need to go to the right or to the left to get to the next C? 8 times, right? So that's where the name of the law of octaves comes from, right? Where we've got octaves on a piano or on a musical scale, and it repeats A, B, C, D, E, F, G, and then starts over again, A, B, C, D, E, F, G. So John Newland said, hey, the elements do that too. That's kind of interesting, kind of weird. Let's make a periodic table like that. Let's work on these patterns and use them to our advantage, all right? So he said, let's make kind of a scale, right? A musical scale, but with the elements, right? And I'm using shapes here just to kind of illustrate how this works, where what's our first shape going to be at the top here? Circle, right? And then we have triangle. What about this one? Square, hexagon, and, or sorry, this is a pentagon, not a hexagon. And then hexagon, right? So does that repeat every single row? Yeah, it does, right? So this pattern of the different shapes repeats every single row. As we do that, and as other scientists did that with the elements, they noticed trends. So looking at just this arrangement of shapes, what is a trend that you can give me that goes up the table? Gets smaller as it goes up. So we could put size as that, right? What about going left to right? Talk with your partners, and I want to come up with 2 or 3 different trends that we could have. Right? Take just 1 minute. All right, so I'm hearing a lot of really good answers so far. The obvious one, guys, bring it back together now. Bring it back together. All right, what was the first one that you guys saw? Color, right? So we can say that we're following, what is it, Roy G. Biv, right? Roy, not right clicking, Roy G. Biv, right? Kind of follows that order, right? What was the second one that you guys found? I heard a couple of different answers for it. Change in shape. What's another way we could say that? Number of sides, and I heard a third one out there. Number of angles, right? So we can say, okay, circle's got 0 sides, triangle's got 2, square 4, 5, and 6. Or sorry, 3. Forgot to skip 2 numbers instead of 1. Thanks for catching me on that. That's all good. You know what? It shows me that you're paying attention, so thank you.
Hey, big, small to big.
Right? Yeah, so it's going from small to big on the number of sides. You could say that it's changing, oh, small to big, you mean it up and down? Yeah, we already covered that one. But yeah, so you guys picked out some really good patterns. So what do you think someone would do to try and do this for the elements? Right? Do you think they did the same activity we just did? Yeah, actually they did. Mendeleev said, hey, I'm going to write all the elements I know onto some cards, right? At the time, they only knew 63, right? Which is okay, right? We filled it out, obviously. If you look on the periodic table on the wall, we obviously have a lot more than 63, right? But he took the ones that he knew. This one's on page 11, just as a reminder, page 11, right? He took a bunch of cards with the names of the elements, the properties that they knew about it. So like if it was a solid, a liquid, a gas, maybe if it was conductive or not, they took a look at all of those different things, which by the way, what is something that's conductive? A metal, right? Someone give me an example of a metal while we're on. Titanium, platinum, copper, right? What is it? Uranium? Yep, that's a true one. All right, what else over here? Gold, awesome. Cobalt, yeah. These are some awesome examples, and you guys are all right. Metals do conduct electricity, right? So Mendeleev said, all right, I'm going to take all these cards and I'm going to do something to try and make an organized table and make repeating patterns. So this is what he ended up making. He ended up saying, all right, I know that helium right here is going to be a gas. And I know that it doesn't react a ton. And I also know that neon doesn't react a ton, and it's a gas. So I'm going to put them together, right? Kind of makes sense, right? And he says, okay, lithium and hydrogen, those also react a lot, right? They react almost the most, right? So I'm going to put them on top of each other. So things with similar characteristics got sandwiched on top of each other, right? So what I'm going to do is I'm going to ask you guys to do this, not with the elements, but with this list of animals, right? I want you guys to use maybe, yeah, no, Harry Potter is not on there. He's not really an animal that would fit in this. But I want you guys to take this list, work with your partners for about 5 minutes, use that bottom right page or bottom right space on your page. Give me a chart kind of like this one, right? Where you've got one trend going up and one trend going to the right. All right, using these animals. All right, I'm going to give you guys, again, 5 minutes to do that. And then we'll come together and I'm going to show you just one example because there's no wrong or right answer to this. Well, maybe. If you put polar bears on there, I'd be really sad because polar bears aren't on the list, all right?
Tabasco snake that tries to kill people by looking at it.
So I'm talking about the basilisk from the movie Harry Potter. I'm not talking the mythological one. I'm talking the big old snake that like petrifies people. It's like the size of a bus, right? So that's the basilisk I'm talking about, not the real one or the mythological one. Hey, I needed a big snake. Well, you know, I needed another snake on there. If you need to, you can use your phone to really quickly look up the size of some of these things. Well, you can look it up, see what it is. All right, I'm giving you guys the chance to use your phones to look it up really quick. And then when we're done, we're going to put those away, right? Yeah, that is freaky. Yeah, that's totally good. That is a great way to start. I like it. Nice job, Meg. Let's see, open up those. Also, I got to say, I love all of the Western wear today. Good job participating in Spirit Week, guys.
What is bigger, a pit viper or a tabby cat?
Pit snakes can fit in your hand. Oh yeah, for clarification, tabby cat just refers to like a house cat. So it's like a little scrawny orange yellow cat. Yep, everything on there should fit in one table. There's 15 of them. It's not too bad. Wait, say that again. Did I hear a question? All right, so to answer some questions that I'm hearing, because you guys don't have service in here to look it up, the pit viper is something that you can hold in your hand when it's all balled up. Tabby cat, I mean, like you guys have seen house cats, right, wandering around. Or
what about when the pit viper is all the way out?
Well, is a pit? I mean, like coiled up. Corn snake is something that could like snake around your fingers, right? A lot of people who have those as pets do that because they're really, really small. All right. Corn snake is going to be a small snake, right? Pit viper is going to be a little bit bigger.
It's a boa bigger than
I would personally say that the anaconda is bigger than a boa constrictor. There could be a really massive boa constrictor, but that's just my opinion on that. All right, and then I would also say that a lion is bigger than a tiger and a mountain lion. It's not? Oh, sorry, excuse me, misspoke there. The tiger is going to be bigger than the lion and the mountain lion. All right, I'm going to give you guys about 1 more minute. Parakeet is something that can fit on your finger. Parrot is something that would sit on your shoulder. All right, so I'm going to give you guys about 1 more minute to wrap this up. All right, and then we're going to go over just one example that would suit this. All right. Sorry, I was covering it for a second. There you go. Yeah, some hummingbirds can be really small, really, really small. All right, from what I can tell, the conversations, I think we're about done, right? All right, so let me pull up the Smartboard notebook, right? And I'm going to just draw out for you really quick an example that would work pretty well for this, all right? Right, or at least the framework for it, right? So again, we started with, that was rough. All right, let's try this again. There we go. All right, so we started with this sort of framework, right? So something that I saw quite a lot was size, right? Size was what you guys typically put on this axis, right? And then after that, I saw quite a number of things. My favorite, personally, number of legs, right? How many legs do snakes have? 0, right? What about birds? 2. Cats? 4, right? So that's one that I personally quite like because it follows a trend, right? So then what would the smallest animal be that only had no legs? Corn snake, right? So I'm going to put CS there just to abbreviate that. All right, what about what has 2 legs and was the smallest? Hummingbird, right? 4 legs? Yeah, the tabby cat, little house cat.
I went biggest to smallest.
And you could totally have done that too. You could. That is all right. It is okay, right? The goal was to figure out a pattern, all right? So 0 legs, what would have been the next one? Pit viper, right? Right, what about for 2 legs? Parakeet, all right. 4 legs? Mountain lion, what about a bobcat?
Oh, there's a bobcat on the list?
There was a bobcat on the list.
Never mind.
5th one, 6th one down, right? So the idea is that you can see this pattern, right? Where we've got 0 legs, 2 legs, 4 legs, 0 legs, 2 legs, 4 legs, and onward through the rest of the list, all right? So this was, again, just to kind of give you an idea that, yeah, these elements are really crazy and there's a lot of them, right? But there is patterns to them, right? Just like there's patterns to this really weird hodgepodge of a list of animals, right? All right, so let's go back to our notes here. So we covered that Mendeleev did this activity with cards, right? And he made the periodic table, or at least the beginnings of it.
Yeah, why is helium on the wrong side?
Well, because that's how he wrote it, right? What we found out later is that all of the elements have different atomic numbers, right? We talked about atomic mass, right? If atomic mass is unique to each element, are atomic numbers also unique to each element? Yeah, so could we figure out patterns using those too, you think? Maybe, right? That's a good idea too, but.
Nice.
So what we do is we look at our periodic table, the one that we've got on the wall over here, I want you guys to look at the red numbers underneath the name or the symbols of the elements, right? Those are the atomic mass, right? The red numbers. If we go through hydrogen, less than helium, good. Lithium, less than beryllium, awesome. We go through all the way down the list, but then we get to cobalt and nickel. We say, all right, iron, less than cobalt. Cobalt, less than, wait, hold on. It's not less than nickel, right? Nickel has an atomic mass of 58.6 and cobalt is 58.9, right? What matters now and what we use in our periodic table is the atomic number, right? So the atomic number on that periodic table, you can find where you've got, let's say it's element Q, right? The number, the atomic number at the top, in the top right corner, that's going to be your atomic number. And that's what we organize the periodic table with today. All right, so what we're going to do now that we know what makes up the periodic table, how it was made, I'm going to show you guys how we can use this really, really well. I'm going to tell you right up front, I'm going to give you guys like 3 descriptions for an element. And I promise you guys are going to be able to pinpoint exactly where the periodic table or where on the periodic table it is, whether that's naming it or telling me which zone it's in. All right. So this is when you're going to pull out your periodic table. I'm going to tell you guys, we got 3 periodic tables on this piece of paper. All right. When you guys got it, it's this nice big periodic table. I want you guys to all hold it in front. Hold the big periodic table to me. Show me it. Biggest periodic table. Awesome, awesome. Now that it is towards you, I want to take the sides of it, bring them towards your face, not away from it, right? And I want you to, or sorry, away from your face. Got to remember how to mirror myself, right? So I want you guys to fold it so the big one is inside the whole paper, right? Awesome. Great job, guys. So now, if we ever refer to a periodic table in class, if I say, hey, I want you to pull out the big periodic table, I'm asking you guys to pull out the one that takes up the whole piece of paper, all right? If I ask you to take out the half periodic table, you're going to pull out this one where it's only got a little bit of the periodic table on there, right? It kind of looks like the one that Mendeleev made that we saw on the slide, right? And if I say, I want the small periodic table, I want the one on the other side where it's going to have this nice big space in the middle, right? And this is the one that we're going to color on, all right? We're going to label, all right? Now don't color on it yet, all right? Because what's really cool about this periodic table is you guys can use it on your test, all right? This will be an awesome help on your test, but if you write something on there that you're not supposed to, we're not going to let you keep it, right? If we're really mean, we might not even let you take the periodic table at all on your test, all right? So whatever I put on here, you can put, right? You could give yourself a little smiley face, draw a little happy person dance and give yourself some encouragement on the test, right? But I don't want you to write the names of any of these elements on here. I don't want you to write, anything else besides what we tell you, all right? Because I want you guys to be able to take the test with the most tools possible. Sound good? All righty, so let's get started labeling this thing. All right, so first we're going to start with families and periods. Now, before we go any further, families right here, that means column. All right, and period is row. So when I say period, you say what? When I say family, you say what? All right, when I say column, you say what? All right, and when I say row, you say awesome. So get that drilled through your head, right? I know it's a little weird. Every now and then through the rest of this lecture, I might say, hey, period. You guys are going to say row, and I say row. No, don't say row, 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 you boat. That is a good song. But if I say row, you're looking for periods. Thank you, Luke. So we're looking to figure out the language of the periodic table while we're making this, all right? So we're going to start naming the families first, all right? So what I want you to do is I want you to put a Roman numeral 1 over that first column. Yep, I want you to do it on the small periodic table. You're never going to draw on any of the others. All right, you might in Chem B, you might do it in another unit, right? But for this unit, this is what we're doing. All right, so 4, you can use your pencil, just a regular pencil for this one. I'll tell you when you can use the colored pencils, all right? So you're gonna do Roman numeral 1, 2, and then you're gonna skip all of this, right? Skip this big old block. We're not touching it, right? Then you're gonna resume and do Roman numeral 3, and you're gonna finish on Roman numeral 8, if you do your counting, right? Yeah, so it's families 1 through 8, Roman numeral 1 through 8. So, oh, sorry, I forgot to ask. So Roman numerals, all right, let me see if I can get a free page. All right, Roman numerals got 1, 2, 3, 4, right? V means 5. So if I put a 1 before the 5, that means 1 less than 5. What do you think happens when I put just the 5? Or sorry, I told you guys that answer. So what happens if I just put the V and then an I or a 1 after it? It's 6, right? So that's how Roman numerals work, all right? And then we'll have 7 and then 8. I'll put it over here because I'm running out of room on the bottom. 8 is V with 3 I's, all right? Awesome, awesome. So you've got all those columns labeled. Now what I want you to do is you've got a big space right in the middle of your periodic table, right? Make sure you fold it. That'll help you out so you know how much space you have. So in the middle of your periodic table, I want you to take just a little bit of space and whoa, I don't know what happened there. All right, so you're gonna put 1, 2, here, let me put it down here. So you're gonna put 1 and 2, and then you're gonna skip over to 7 and 8. All right, put that in the middle of your periodic table where it says key to markings. So let me pull up here. We'll use this one for now. So put your period or your Roman numerals here in that space that's given you, all right? So just make them small enough because we're going to add more to it, right? So but just put 1, 2, 7, and 8 for your Roman numerals, all right? And then next to the Roman numeral for 1, I want you guys to put alkali, right? A-L-K-A-L-I. All right, again, keep it kind of small because we're going to add some more to that. But from what I can tell, you guys are keeping it right, just the right size, all right? For number 2, I want you to put alkaline, right? So spelled the same, but we add an N-E, and then earth. Helps if I can spell earth correctly. So alkaline earth for Roman numeral number 2. And someone remind me, what is Roman numeral number 2? How many I's do we have? 2, right? All right, Roman numeral 7. This one, right? Again, that should be in the key to the markings. Awesome, seeing that. Good job, guys. You guys are gonna say it's a halogen. Right? Who here's heard of a halogen light bulb? They're kind of going out. We're switching to LEDs, so all right, I've got to come up with a better example for halogens, I guess. But halogens are going to be in that column that you've labeled 7, right? You know what the next one is? What's the next one, Luke?
Noble gases.
Noble gases, exactly, right? Good job. Someone's been reading ahead. No, you're just that smart. All right. Oh, Bert's class. Yeah, Bert covers a lot of really good stuff. All right, so for Roman numeral 8, you're going to put noble gas. And again, remember, these should go, right? You're going to have 1 and 2, and then Roman numeral 7 right above fluorine or F. Right, nice job. All right, we good on labeling those things so far? Just for labeling the different names of what are these if we're naming columns? Families, right, yeah. All right, so we've got that. Let's go back here. All right, the last thing you're gonna do for families and periods is we need to number the periods, right? So I'm just going to go 1, 2, 3, 4, 5, 6, and 7. Right? So you're going to do hydrogen is your first period. And then francium, FR, at the bottom left, is going to be 7. So fill in those numbers. Francium is what that one's called, yeah. Right? Elements are pretty cool. All right, now for this block at the bottom, all right, you guys might be wondering, hey, these guys should be 8 and 9, right? Who thinks that they should be 8 and 9? No, man, you guys are on top of it. I like this. So 8 and 9, where do they fit? They really fit right in here. It's hard to draw on this, but that's what those are supposed to go, right? So that's actually 6 and 7. All right. So already I can say, hey, McKee, I need to know an element that is in the halogen family, and it's in period 5. Yeah, halogen in period 5. Which element am I talking about? Iodine, exactly, right? All right, who else wants to be quizzed? I know it's a horrible question. Who wants to be asked a hard question? Oh my gosh. 267s. Oh. Yeah, no, I can cover it again though. So this chunk right here, very hard to draw that in there. That chunk right there is supposed to hit here. Yeah, you can totally put an arrow like that. That is fine. Yeah, or you could add stars to it. That also helps. Right? If that helps you to remember where those actually fit on the periodic table, because we'd have to print really big papers. Right? So if you look, take a second, open up your periodic table to the big periodic table. Right? And it doesn't have it printed out like that, but that's the size of piece of paper that we would need to print the whole periodic table as it's supposed to be written. All right, but to save on space, right, we just take that chunk out and let everyone know, okay, it's supposed to go right there. Kind of makes sense. It's kind of weird, right? Feels like we should be printing with more paper, right? All right. Let's go ahead and look at gases and liquids. So now I want you to take your first color, right? I want you to take, let's say maybe green or blue or purple, again, whatever color you want to do. All right, and let's see now. Let me make sure I can get my colors up. All right, I'm going to use orange. All right, so I've got orange, and I'm going to label up in this section gases. All right, now the gases we've got are going to be hydrogen. What I want you to do, guys, is I want you guys to color it in. You could outline it. You could draw a little pattern in it, whatever you got to do to quickly fill in hydrogen lightly, because we'll be drawing in a couple of letters and numbers in these later. So you want to be able to see through whatever you're coloring. So I want you to do hydrogen with, again, just one of your colored pencils, whichever one you're designating as a gas. And then after that, I want you to do everything between helium and, where'd the pen go? There we go. And radon. So that whole column. Then I want you to do everything from nitrogen. Sorry, that scribbling turned out a little bit weird. I want you to do everything between nitrogen and fluorine. And whoa, that turned out really weird. Okay. And then I want you to do chlorine. I don't know what's happening there. I want you to do chlorine, bromine, and iodine, or iodine. Or sorry. Before you do bromine or iodine, I misspoke there. Do not color those ones in. Those ones have different ones colored in. Sorry. Yeah, color in chlorine, right? So you're gonna do, basically you're making this elbow here, right? And then chlorine likes to be included too. Exactly, yeah, I heard it in the back. Thank you so much. So if you want to look at the periodic table on the wall, it's got all of the gases in a red text color. I know this slate is a little bit rough. I need to practice with it a little bit more before I can label it better. All right, so that's how that one's going to work, right? We're going to color in our gases Again, let me try and get a different color so it'll stand out better. Try red, go back to red. So gases, again, they're helium to radon. Oh, weird. And then chlorine is included. And then we've got nitrogen all the way to fluorine. And hydrogen's weird too. All right, yeah, we want to go a little bit quick because we want to make sure we cover everything. So there's a lot you guys are going to be putting on this, all right? Let me make sure. I know it's hard to be coloring. Yeah, sorry, that's my bad, but it's all good. You'll be able to figure out now, right? Awesome, awesome. Yeah, that looks great. All right, so now we're going to go ahead and do the liquids because from what I can tell, you guys are handling this pretty well. All right, so for liquids, yeah, you could use blue, whatever color it is. You just want to make sure it's a different color, right? So I'm going to use blue and I'm going to write liquid. You want a different color? Oh, okay. Yeah, awesome. If your color ends up being the same as the color you'd already used, go ahead and just trade with a partner. Thanks for working with yourselves, guys. All right, so for liquid, how many liquids do we have on the periodic table? I think a couple people have been saying it. I see a 2 over there. Got a couple of head nods and averting of eyes. They don't want to meet my gaze. It's because I'm like a basilisk. I'm not from Harry Potter, guys. I promise. Not going to turn into stone or anything. But yeah, so we've only got 2 elements in here that are going to be liquids. We've got bromine, right? So you're going to go ahead and color bromine in, right? And you're going to also color in mercury. All right, so again, let's do a quick check-in. If I say, hey, I need a liquid at room temperature, which by the way, all of these, when I say gases or liquids, this is because they're at room temperature. Right, so I can freeze bromine and I can freeze mercury, but at room temperature, where we're at right now, these are going to be liquids, all right? So if I say, hey, I need a gas, right, that is in the halogen family, and I need it to be in the 3rd period. Which one am I talking about? Need a gas in the halogen family. Gas in the halogen family in the 3rd period. I heard it over here. I want to hear it over here too, though. Argon. Or 3rd family, or third period, sorry. 3rd period, halogen family, right? And I need it to be a gas. It's chlorine, right? Good job, guys. Yeah, so again, if I say maybe, oh, I need a liquid at room temperature that conducts electricity, which one is it going to be?
This one.
It's going to be mercury, right? Yeah, because it's a liquid at room temperature. And as we'll for sure know in a little bit, mercury is a metal, right? All right, so now I want you to take your 3rd color. We're not labeling solids. All right, so if I just labeled gases and liquids with one color, do I need to color in the solids? Everything else on there is going to be a solid, right? So we don't need to spend time coloring in the whole periodic table, right? All right. So the next thing we're going to look at is metalloids. Let me get another color just so I can be consistent with you guys. Let's see, let's use green. All right, so our metalloids, these are going to be following what's called the staircase, all right? And you guys have that showing already on your periodic table. It starts with boron. Whoa, that's weird. It starts with boron, and then it goes down in between. Oh, that's going to be a day, isn't it? All right, so it goes down in between aluminum and silicon, then underneath silicon, and it follows that thing. So I want you guys to take your 3rd and final color and fill in. Well, I'm not doing that yet. I'm just asking you guys to do the staircase. Just the staircase that's in there, all right? Yep, and thank you for reminding me, guys. So you should use, again, in your key, you guys have a little bit more room than I do. So Metalloid is what you're going to put up there, all right? Yep, so do that. And when you're coloring in your staircase, really make it stand out, right? So the staircase goes from boron down. So just follow that space, and then I'll tell you which ones to color in just a second. So just, yeah, just color the staircase right now, just the line. So yeah, again, we're just coloring in this line. Where'd my marker go? There it is. So we're just coloring in that little gap that you guys see on your periodic table. All right. Awesome. Now, if you're done with the staircase, what I want you to do is I want you to color in every element that touches it except for aluminum. All right, aluminum's a metal, right? But you're going to color in boron, right? So we can color in boron, we can color in silicon. Does carbon touch the staircase? Does it share a side with our little staircase that we've got?
It has like a little corner.
It's got a corner, but we're looking at sides, right? So you can go color in boron, silicon. That's okay. That is okay. You can use an eraser. Sometimes colored pencils can erase. All right. All right.
I don't know if it's gonna be okay.
Yep. So don't color in carbon, right? But you can color in the GE. You can color in arsenic, antimony, the TE here, polonium, and AT. All right. But again, we're not coloring in aluminum or AL. Yeah, we're not coloring in aluminum. All right, and that's going to be our metalloids. All right, and if you messed up and you colored in carbon or something that shared a corner with it rather than a side, that's okay. Again, erasers exist and they work decently well, right? I'm going to change pen colors really quick. So we got one thing that we want to add to this, really, really important. All right. So if we've got this nice little staircase right here, right? And let's say we'll take a look at oxygen, right? Don't want you to draw anything just yet unless you're still filling in your staircase. But I want someone to tell me, is oxygen a metal, a non-metal, or a metalloid? Non-metal, right? It doesn't conduct electricity. It's a gas, right? So what I want you guys to do is I want you guys to write non-metal on this side of your staircase in regular pencil. You can do it in regular pencil, all right? And then you can write metals on the left side of your staircase. All right, again, you can do it in pencil, pen, just your regular color, all right? Sound pretty good? All right, again, we should be using light colors, right? Or just faintly drawing in these boxes. All right, we're gonna speed through this last part, but it's pretty quick. All right. Can someone give me a thumbs up if we're good to go, or if we need a little bit more time coloring? Pretty good. All right. So the last two things that we're gonna label is diatomics, right? Now, what you're gonna do is you're gonna put a 2 under the hydrogen, right, in the bottom right corner. So let me make this a little bit bigger for you so you can see what I'm talking about, right? If this is element Q, right, I would put a 2 there, right? So it's just a made up element. So you're going to do that for hydrogen. You're going to do it for nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, right? So you should make this kind of 7, a 2. Oh. So you're going to do that on hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So you're going to make this kind of 7 shape, right? If you see the ones that have 2s make a 7 shape in here, right? So just put a little 2 using your pen or pencil, put a 2 in those. Awesome, awesome. Yep, bromine and iodine. So Br and I. Awesome, good job, guys. All right. Now the next one that we're going to do is if something is toxic or colorful. All right, there's only a couple of these, so we'll go pretty quick. All right, the toxic ones, you're going to put a T in. All right, so T, we're gonna put a T in the mercury, and then we'll put a T in the lead, and then we'll finish this up tomorrow, all right? Thank you guys for paying attention and good job coloring. We'll finish this up tomorrow. Have a great day, guys. Yeah, you can just leave the colored pencils out because we're going to use them for the next class too. Thank you guys so much.